Alright, so to graph secant and cosecant, you need to remember that the reciprocal of secant is cosine, or remember that the reciprocal of cosine is secant, and the reciprocal of cosecant is sine, or the reciprocal of sine is cosecant. So we have to use its reciprocal function to help us graph. So let's say I wanted to graph y equals 2 cosine of 1/2, sorry, not cosine, cosecant of 1/2 x. Alright, so let's say we want to graph y equals 2 cosecant of 1/2 x. Then what I have to do is I have to use its reciprocal function. So the reciprocal of cosecant is sine. Write down the exact same amplitude, the same omega. So everything looks the same except I've just changed the function over to its reciprocal. Now work this out like we were graphing y equals to sine of 1/2 x, because we actually do have to graph it to help us with the graph of y equals to cosecant 1/2 x. So the amplitude is equal to the absolute value of 2, which is 2. The period is equal to 2 pi divided by omega, and omega is 1/2. Flip and multiply. Those don't cancel out. Flip and multiply, and you'll have 2 times 2 pi, which is 4 pi. Alright, so we want to draw one period of this graph, at least. One period can be drawn between 0 and 4 pi. Alright, so we take now the period, divide by 4, so that we can get the value that we add to each significant point to get the next significant point in our subintervals. So I'll say the period divided by 4, so 4 pi divided by 4, that's pi. Alright, now I have 4 subintervals that I'm going to make. It's going to help me figure out my significant points on the x-axis. I know that I start at 0, I know that I end at 4 pi. Alright, the way that I get the first significant point past 0 is I take that increment that I figured out and I add to 0. So 0 plus pi is pi. You start the next subinterval with the last point in the previous subinterval. So pi, and add pi to that. You get 2 pi. Repeat the process. 2 pi, add pi to that, you get 3 pi. Now here's where we can check ourselves and make sure that we figured out the right thing to add to each significant value. 3 pi, add pi to that, you get 4 pi. So we ended where we were supposed to. Okay. Now we're going to proceed and graph the sine function. Alright, so I'm going to give you a rough sketch right here. Alright, so our amplitude was 2. That means I'm going to have a high point of 2 and a low point of -2. Right, I make my own scale on the x-axis, and that's okay as long as I label my points. Alright, so this is 0 on the x, this is pi, 2 pi, 3 pi, 4 pi. Alright, and I'm going to sketch first y equals 2 sine of 1/2 x. Now we need to know the basic shape of the sine curve. The sine curve at 0 starts at 0 on the x and y, right at the origin. At the next significant point past 0, sine has a high point. Next significant point, sine will cross. Next significant point, sine has a low point. At the last significant point, it will cross. Alright. Connect the dots with smooth curves. And that is one complete period. Now, that's y equals 2 sine of 1/2 x. We want to graph y equals 2 cosecant of 1/2 x. The way that we do that, everywhere that the sine curve crosses the x-axis, we have a vertical asymptote. That's because, think about it, when sine is equal to 0, so like say the sine of 0 equals 0, cosecant is 1 divided by 0, so cosecant is undefined. So that's why we have vertical asymptotes. So anywhere that the sine curve touches the x-axis, put a vertical asymptote, you just draw a dotted line. Alright, and remember the domain for sine. If this would have just been sine of x, the domain would be between -1 and 1. Well, since it's 1/2 x, the domain is between -2 and 2. The domain for cosecant, remember, is everything greater than or equal to 1, less than or equal to -1. So it's going to be everything greater than or equal to 2 and everything less than or equal to -2. The way we can draw that, at every high point, you draw a U-shaped graph going up that approaches these vertical asymptotes, and at every low point, you draw a U-shaped graph going down. Now, I know it may not be as easy for you to do, but just pay attention to what I'm going to do now. If I was to erase the sine curve, then that is cosecant. And it looks just like that without the sine. Right? But I'm going to go ahead and draw that back in, just because I have it labeled at the top. Alright, let's take a quick view of what that would look like if we graph that on a graphing utility. Alright, so if I wanted to graph that, my graphing utility here, I'm going to first graph y equals 1/2 sine, no, I'm going to first graph y equals 2 sine 1/2 x. Alright, so you can see that graph is stretched out. Can't even really get a good picture of it. Now, on that same graph, I'm going to add what our original problem was 2 cosecant 1/2 x. So you see, now we don't have the vertical asymptotes drawn, but at every high point you have a U-shaped graph opening upward, and every low point you have a U-shaped graph opening downward. So I mean, you can just imagine that there's a vertical asymptote here. There's a vertical asymptote. Ooh, move that over a little bit. There's a vertical asymptote here. And there's a vertical asymptote here. Anywhere that the sine curve crosses the x-axis. Alright, let's take a look at the graph y equals negative secant 2/3 x. Alright, so the first thing we want to do is to write down its reciprocal, which is cosine. So I have to use the cosine graph to graph secant. So y equals negative cosine of 2/3 x. Alright, the amplitude is equal to, what's the number in front of the sine, the cosine or the secant? Negative 1. So the amplitude is going to be absolute value of negative 1, which is 1. Now keep in mind that when I do have a negative in front of something that I'm graphing, a trig function that I'm graphing, every high point is going to become a low point, and every low point is going to become a high point. So that's going to be flipped. And we'll address that when we get to the actual graph. Alright, the period is equal to 2 pi divided by omega, or 2 pi divided by omega is whatever's in front of the x. So 2/3. You take and flip the fraction, and we'll have 2 pi times 3/2. So that means that our period is 3 pi. So we're going to draw one complete period and label the graph correctly. Alright, I can draw one complete period between 0 and 3 pi. Alright, I need to figure out the 4 subintervals of this graph so that I can figure out significant points. Significant points or key points are places where we're going to have high points and low points and cross the x-axis. So to do that, and again I said I'm going to have 4 subintervals. To do that, you take the period and divide by 4 first. So the period is 3 pi divided by 4. Well, that's 3 pi over 4. Alright, so I'm going to take 3/4 pi, and I'm going to add to each significant point so that I can get the next one. Now, we know if the entire interval is between 0 and 3 pi, I'm going to start at 0, I'm going to end at 3 pi. Okay? So let's see if we can do this. Say 0 plus 3 pi over 4. That's 3 pi over 4. Now, the next subinterval starts with 3 pi over 4. We want to add 3 pi over 4 to that. So that's going to be 6 pi over 4. So 6 pi over 4 will simplify to 3 pi over 2. The next subinterval starts at 3 pi over 2. We add 3 pi over 4 to that again. Recall that was 6 pi over 4 before we simplified. So 6 pi over 4 plus 3 pi over 4 is 9 pi over 4. Alright, now this is where we can check and see, did we add all of our fractions correctly? And did we choose the right increment? Or did we figure out the right increment? So I'll take 9 pi over 4 and add 3 pi over 4 to that. That's 12 pi over 4. And 12 pi over 4 is equal to 3 pi. So that means that I did all of my significant points correctly. Now the way that I use these significant points or key points on the x-axis, so I'm going to label these. This is x equals 0. Then the first significant point past 0 is going to be 3 pi over 4. The next significant point past 0 is 3 pi over 2. The next significant point past that is 9 pi over 4. And the last significant point in the graph that we're going to make is 3 pi. Alright, the amplitude was -1. I'm sorry, the amplitude was +1. So that means that we're going to have a high point of 1 and a low point of -1. Now the original was negative, so that's going to flip every high point and low point. Cosine usually starts at +1. Since it was negative, we have to start at -1. Cosine usually crosses at the next significant point past 0. It's still going to cross. Then we usually have a low point, so that means we're going to have a high point. Next significant point, we cross. Last significant point, we usually end at a high point. Since it was negative, we end at a low point. Now make sure you don't just make a V here. You want to connect the points, smooth curves. So that will be one complete period for y equals negative cosine 2/3 x. Now that's not what the problem asks us to do, but we have to use that so that we can graph y equals negative secant 2/3 x. Alright, so the way that we graph y equals negative secant 2/3 x, every place where this graph crossed the x-axis, we put a vertical asymptote. At every high point, we draw a U-shaped graph opening upward. And every low point, we draw a U-shaped graph opening downward. Alright, let's see what that would look like in the standard graphing window. So I'm going to throw both of these graphs up here so we can take a look at them real quick. Let's say I have negative cosine of about 3x and negative secant 2/3 x. Alright, so the blue curve here, this is y equals negative cosine 2/3 x. Notice it does start at a low point. Alright, and then you see the red graph here, that's negative secant 2/3 x. And so we could just imagine that every place where this crosses the x-axis can have a vertical asymptote. Alright, so that's both graphs.